Okay, I'm going to go over some examples on how to write formulas. The first thing we're going to look at is aluminum sulfide. So remember to do your symbol and your charge. So aluminum has a 3+ charge because of its location on the periodic table. Sulfide has a 2- charge. And what happens right here is these numbers, these charges, need to equal 0. So the easiest thing to do is to swap and drop, which means that the 2 is going to come down behind the aluminum, and the 3 is going to come down behind the sulfur. And when it does that, you don't take the charges, you just take the numbers. So then what ends up is Al2, S3. And that would be your final answer right there. Now, when we look at this, it makes sense logically and mathematically. So for example, aluminum has 2. So if we write out the ions again, there's 2 aluminum ions. Each sulfide ion has a 2- charge. So notice what happens with your charges right here. That's going to equal a 6+. Right here, that equals a -6. And a 6 and a -6 are going to equal 0. So when we swap and drop, it makes the compound neutral, which is why we swap and drop. It's just easier to do mathematically. You can also do this algebraically, but again, way easier to just do it mathematically. Let's do another example. Let's do cobalt, Roman numeral 2 oxide. So once again, do the symbol and charge. So cobalt, CO, charge is a +2 because of the Roman numeral. And then oxide has a -2 charge because of the fact that it's in group 16. So here notice that your charges are the same numerical value, but opposite charge. So what happens is they just cancel. So in order to make this compound neutral, we only have to have 1 cobalt and 1 oxygen. So your answer is just going to be CO. Oh, and that's your answer for that one. Okay, let's do another example. Let's do iron 3 carbonate. So iron, Fe, our charge is at 3+ because of the Roman numeral. Carbonate ends in 8, so that's a polyatomic ion of CO3 with a 2- charge. Notice how your charges here do not cancel. So what we're going to do is we're going to swap and drop. So the 2 is going to come down behind the iron. The 3 is going to come down behind the carbonate. So let's look at what that would look like. Let's draw that out. So we're going to have Fe, and then there's the 2, showing that we have 2 atoms of iron now. And then, because our charge here is 2 or greater, and we're dropping down to something that has more than 2 atoms, we have to do parentheses around the carbonate. So we're going to do parenthesis, CO3 in parenthesis, and we'll put the 3 behind there. And that would be your answer. So let's look at this mathematically. Right here, we've got our 2 irons. So I'm just going to draw this out so you can see the charges. This is telling us right here that we have 3 carbonates. So if we write that out 3 times. Okay, now let's look at our charges. So our charges here, that equals a 6+. Right here, that's going to equal a -6. So again, that cancels out. So here is your answer right there. Without that. Oh man, now I'm just making it look messy. Okay. And that would be your answer. That's a 3. Okay, I hope this helps. Let me know if you have any questions. Thanks. Bye.